everyone, I'm Tony Rodriguez, and this is my statistics project. Some of you might be wondering why I haven't yet shown you an intro to a music video that consists of a bunch of short clips of me and some of my classmates looking at textbooks for a few seconds, followed by all of us doing some unchoreographed dancing for the next few seconds, all to the tune of me trying to sing about preparing for an AP Stats exam to the tune of some recent song that will become obsolete after a few years. Well, for this video, I wanted to challenge myself and try something different. Something that would show my true potential as a statistics student, but also give all of you watching a good amount of entertainment. I just can't seem to think of any good ideas yet.
Tony, come here!
Oh, right on cue. What's wrong, Evie?
Can you help me with my homework?
Sure, so here just look at how many students chose fish and... Wait a minute, hold on. This bar graph looks so much like my statistics homework from last year. Maybe this is exactly what I need for my project.
What project?
Come on, I'll show you. So here's what my project is based on, this graph that I found from my sister Evie's homework. Say hi, Evie.
Hi.
While I was looking at this bar graph, I thought about how I could apply the statistics that I've learned this year as an 11th grader to this first grade math homework. My brain told me, if you really wanted to run a statistic test on this simple bar graph, you could. Not that you would, but you could. And because I'm way too curious when it comes to things like these, I did. You ready for me to explain this, Evie?
Yes!
Alright, so my first step in the process was to consider what I actually wanted to test. I figured that since the graph has categorical variables, I should run a chi-square goodness of fit test on it.
Oh, interesting.
So then I had to form my hypotheses. Now, since the only background information explicitly shown on this entire graph is that it has the title favorite pet, and that the four choices are bird, cat, dog, and fish, I didn't have much to work with as for how I would determine if the data were random. The only information I even got about who was picking their favorite pet came from the problem below the graph. However, I decided to work around this by clarifying that I'm not generalizing, that the students that I am generalizing to are students like these, not just all students. So my null hypothesis was that these pets are equally preferred by students like these, and my alternative hypothesis was that these pets are not equally preferred by students like these. My next step was to check the conditions. Since I already talked about how I couldn't determine randomness and how I dealt with that, I'll talk about the large counts condition. In order for this condition to be met, each expected value has to be greater than 5. For a goodness of fit test, finding the expected values for each category is simple. Just divide your sample size by the number of categories. Because the total number of responses was 21 and there were 4 pets to pick from, each pet had an expected value of 5.25, just above what I needed for this condition. So aside from the randomness, everything checks out, so this set of data works nicely for a statistics test. Now here's the part where it gets a little bit more complicated. Are you ready, Evie?
Yes!
The third step was to use the formulas I needed to run the test. In order to calculate a chi-square statistic, you need to find the sum of the square of the observed values minus the expected values, all over the expected values for each category. I did this to the graph and got a chi-square statistic of 4.33. The degrees of freedom are easy to calculate, just the number of categories minus 1 for a goodness of fit test. This gives us 3 degrees of freedom. Now that I had the test statistic and the degrees of freedom, I then plugged those values into the calculator and got a p-value of 0.228. Now Evie, do you know what a p-value is?
No, what is it?
Well, in case anyone else doesn't know, a p-value is the probability that another sample's data will vary more from the expected values than this sample if the null hypothesis is true. In this case, if these pets are equally preferred by students like these, then the records on how many students prefer each pet will differ from each other more in a new sample of students than in this sample about 22.8% of the time.
Oh.
Now on with the final step, the conclusion. Since our p-value is above the default significance level of 0.05, we fail to reject the null hypothesis. This means that there is no convincing evidence that these pets aren't equally preferred by students like these. Now, even though my results were mostly inconclusive, I feel like this taught us all a lot about inferential statistics. What do you think about this, Evie? What did you learn?
That my brother can turn Easy problems and the hard problems.
Excellent. Thank you all so much for watching this video. I hope this was a nice change of pace for you all, and I hope to see you in the next video. Even though there isn't a next video.